So in Newtonian mechanics, a conical pendulum involves forces. So it's the same kind of a motion. It's a circular motion. And I think I'm going to stick with my normal coordinates, x and y. What are all the forces that are acting on this mass? So in Newtonian mechanics, we worry about the number of masses, right? So it has only one mass. That means it'll have how many equations? 2. Sigma fx and sigma fy. So now the first thing we're going to do is worry about how many forces exist in here. Well, there's always one force that always exists, which is mg. And the other force that exists is which should always act upwards. So remember, this is the tension force, not the period anymore. Sorry, they're both T's. So then again, I'm going to call this L. And I'm going to call this R to be consistent with what we just did. And I'm just going to call this angle theta. This means this, in terms of tensions, is T cosine theta, right? And is this side T sine theta? Yes. Okay, good. So now let's write Newton's equations. Sigma fx and sigma fy. There's only one mass, so we'll only have these two. All the forces in the x direction. Oh, what direction should T sine theta be?
Sure.
And what direction should T cosine theta be?
Oh, right.
Because you have to complete the triangle?
Yeah.
Okay. So that means I can write T sine theta. It is in the positive direction of x. And that's it.
Yeah.
Ooh, okay. And for Fy, we will have T cosine theta minus mg. Now, here's the tricky part. What is the sigma Fx? What kind of a motion is this? Sigma Fx could be either 0, ma, or mv squared over r, depending on the motion it is. It is what kind of motion?
It's a circular motion.
Good. So what's the only option for sigma Fx?
Yeah.
mb squared over r, right? So I'm going to replace that. Good. What is the sigma Fx for the y direction? Is there any acceleration in the y direction? So it'll be just 0.
Yeah.
So could I rewrite this equation as mb squared over r equals T sine theta? And can I write this equation as mg equals T cosine theta? Yes? And can I divide both equations? Get rid of those t's and see one m's and m's go away. Yeah. So then what will you get? You will get v squared over rg equals sine theta over cosine theta. It's just tangent. Wonderful. So that's just tangent. So v squared becomes rg tangent theta square root. I can get rid of this v. That's an equation worth knowing. Now for centripetal motion, what did we say v was? 2 pi r over t equals rg tangent theta. Can I square it, both sides? You see how v becomes 2 pi r over t? Can I rewrite this as 4 pi squared r squared equals rg tangent theta over t? R goes away? Yes?
Yeah.
What am I left with? 4 pi squared r over g. Actually, if I get rid of, okay, can I get rid of the sine? Tangent can be replaced by sines and cosines, right? So it'll be just sine theta cosine theta equals t, right? That makes sense, right? Because I just replaced tangent here. And what did we say R was up here? R was L sine theta. So can I replace R with L sine theta here? So I will get 4 pi squared L sine theta cosine theta divided by G sine theta equals T squared. Ooh, I messed up. There should be a square here. Square here and a square here. So far so good? May I cancel this sign with this sign? What am I left with?
I squared L cosine theta over G.
4 pi squared L cosine theta over G equals T squared. Or T equals 2 pi square root L cosine theta over G.
There we go.
There we go.
Okay, full circle.
It came full circle.
Yeah, definitely dimensional analysis seemed the easy way.
But appreciate what we just have done. We started with a very simple problem, right? It was just a ball attached to a string, and you were twirling it over your head. And then you took the same string and you made it into a pendulum. And then you took the same string with the same mass and you made it into a pendulum like this.